Results. The results page has 4 different sections. The first one has to do with electricity consumption and the BEI. And here it shows graphically the energy consumption of the submitted building. In this case is 118. And this is somewhat lower than the threshold. And that's a threshold set by the EECA. It also shows how this building performs compared to an average office building, national average for office buildings in Malaysia. And here we are also a bit lower. You can scroll down and see some other values, but we'll do that later. Next, we go to an annual energy consumption breakdown. So if, let's say, your building does not comply, you need to resubmit and change your inputs and basically make the building more energy efficient and lower carbon, maybe also on the material side. So this breakdown of the annual energy consumption is quite useful because it shows you where is it that I'm consuming all this energy. So of course the cooling system is a big one. The equipment in the building also, so that's a plug load, also accounts for quite a lot. We have the lighting, various miscellaneous loads, outdoor lighting, and the car park consumption. If we go to the carbon performance, this is really the main page that gives an overview of the 2 thresholds that your submission has to meet. And the first one is the operational carbon, so how much energy consumption and therefore carbon emissions from energy consumption does your building emit. And this is well below the threshold and also of an average, somewhat lower than an average building. So this is basically a mirror image of the first graph we saw under the building energy intensity, except we have converted the electricity consumption into CO2 emissions. The other one is on embodied carbon, and here the building also meets the threshold. But is a little bit higher than an average building, as you can see. So in this case, this building would pass because it meets both the threshold of the operational carbon and of the embodied carbon. On the transport carbon emissions, there is no threshold yet, but you can see it's actually a very high emission, and DBKL will likely in the future also impose a threshold. Maybe not for new buildings, but for existing buildings. But this is yet to be announced. So for now, it's here for as a placeholder and for information that this is actually a significant carbon emission stemming from commuting. At the far right here, under daylight analysis, the portal shows you the floor plan of the building and how far the daylight reaches into the building. In this case, the daylight reach is shown by the blue color, and we put a 3-meter deep daylight reach. So this is that 3-meter deep daylight perimeter zone that is automatically calculated and shown. And it also states in the middle of the floor plan that this is a 3-meter daylit perimeter, and that adds up to about 27% daylight coverage. If we scroll down, and this is the same for all those 4 panes we just saw, it will give some key data. For example, some of the peak demands, both for electricity and for cooling, are shown. And this is useful for the engineers to be able to size up the electric systems, what is the maximum draw of electricity expected. So in this case, it's about 839 kilowatt. For the cooling system, we also get these data out from the annual energy simulation, and we can see that the maximum draw is about 350 ton. So this again would be helpful for the mechanical engineers to size up the cooling system, so we avoid any major oversizing. We also have the maximum cooling demand, and that is the absolute value measured over the year. But these two, often you don't design for that, because that would be like just a short period of time, and it's okay for most buildings to just be 1 or half a degree warmer for those brief periods of time during the year. So often you would design for the other two, the maximum cooling demand, just above. If we scroll down, the software also calculates the OTTV, the overall thermal transfer value. In this case, it's 29, and that's much lower than the required maximum value of 50. It also calculates the RTTV, the roof thermal transfer value, in this case 44, also within the threshold. And it calculates the renewable energy production. This table shows the simulation assumptions and the source of the different assumptions. So the receptacle load is the same as the equipment load that we saw on the graph. We have the miscellaneous loads, which is a fixed value. We have the lift consumption. We have facade lighting. So a lot of these are taken out of the ASHRAE standard down here, which is the American code. We also have a CO2 set point for fresh air. We have a people density and people diversity. So these are both assumed to be fairly high. We have 10 square meters per pax and no diversity. We have an weekly operation of the aircon system of about 52 hours per week. So this is the standard value used by GBI. And we have the thresholds for BEI or the EUI, the building energy intensity or the energy use index, which is essentially the same, set by the EECA. And we have the grid pollution factor of the TNB grid in Peninsular Malaysia in this case, and this is what was reported by Malaysia. We also have the embodied carbon factors for different building materials. This will likely be updated a bit, so it becomes more based on Malaysian figures. And here we have the electricity grid emission factors for Peninsular Malaysia, for Sarawak and Sabah, and just for reference what it is in the EU and the US. The last thing under the results is to export a energy report, which can be done by clicking this button and downloading the raw files, which is basically those input files that were sent to the Energy Plus online simulation. So both of these can be downloaded and reviewed.